Hi guys, Mr. John here. In this video I want to talk about a power supply that I built before. Some viewers of my channel will definitely recognize it. It's this little bastard, but I redid it a little bit, so it works better. In terms of EMI now, the efficiency is still pretty pathetic, 50%, but nah, I don't care really, because it's a small power application. Powers an LED strip here, half a watt worth, and draws 1 watt from the mains. Not a big deal, it's fine by me. I wanted it for a night light, and this piece of, well, not exactly this piece of strip, but that LED strip is glued, is stuck on the aluminum whatever. It doesn't matter where it's stuck. It's stuck to the conductive surface, which is in open air and everybody can reach it. So you cannot use a capacitive dropper there. It's not safe. You need an isolated supply. That's why I opted for a little flyback. But previously it was very noisy. Now it is very clean actually. Surprisingly clean. The radio, which sits about a meter from me, does not catch any kind of radiation from it. That means radiated EMI is low. Excellent. And I went and also plugged this power supply into the same power strip that another receiver is plugged into, and that receiver did not mind having this plugged in as well. That means conducted EMI is also under control, which is fantastic because there is not much to it. You can see I have just this 1 millihenry choke, and that's that. Messy construction, but it works. This layout is actually may not look the most beautiful thing in the world, but it's actually quite smart, to be honest, because you can see that collector of this transistor is so there is a very short track from the collector to the transformer. May be able to see it there. See? Looks kinda crikey, but performs excellent in my opinion. The schematic of this unit is this. Now we get strobing light, excellent. Let me put a bit of shade on it so it doesn't strobe that much. As you can see, in the input we have a single diode, which is okay for this power. As for the transformer is wound on the core that I scavenged from CFL. Let me write some data on it. Okay, so that's some data about the transformer. As you can see there, it's a crude drawing, so you understand what this means. It's the size of the core, EE16/6/6, so it's 16 millimeters this dimension, 6 millimeters that, and 6 millimeters that way. It's a crude drawing, I suck at drawing, but you will understand what is what. The cross section of this core is the area of this little central column. Is about 15 square millimeters. So you can find a similar core in the CFL and use it. But cores in CFL you have too big of a gap in between the halves. Sometimes that's 1 millimeter or more, or a bit less. In this situation we need 40 micrometers. Yes, 40 micrometers. And the way you can adjust the gap really is to take the core, which matches this size, wind the primer, which consists of 290 turns of this fine wire, monkey hair wire kind of thing, and the inductance of the primer should be 29 millihenries. And how do we adjust the gap? Well, one of the halves of the core will have a huge gap, like this. you can see that, or you can't. You see that the central column is a bit shorter than the outer ones. That's a gap. And how you adjust it? You need it to be smaller. So you wind the transformer, 290 turns primary, secondary 28 turns, auxiliary / feedback, this guy, 13 turns. It's the size of the wire, obviously. And you take this and you put it on a sanding stone and you grind the outer legs a little bit, put the core together, put the primer on the inductance meter and check for inductance. You need to grind it in such a way that the inductance will be 29 millihenries. That's the way I did it and it works fantastic. Here's a little demonstration. This meter is the power. It's times 10 range, so it's really 0.93 watts, which is good. Frequency of operation is about 90 kilohertz, even though I calculated the transformer for 66 anyway. And you might ask a question, Johnny, then why does this, you say it works fine? I can't really, it's kind of pointless to show you that the EMI is low. You should you should trust me on this one. It is low. In comparison to other flybacks I built, this is by far this. It's completely silent. I kid you not. The receiver just completely ignores it. There's just a little kinda pop in the speaker when I plug it in, because a little transient when I put in this capacitor charges, and that's that. There is no noise. Previously it was huge noise. And what caused that huge noise? Because I wound the transformer. You may remember this guy from that video. I used Kapton tape to insulate this one, as you can see there. This bastard, the primary here, had the inductance of 2.63 millihenries, when I really need something like 29 millihenries. Yeah, so it's like 10 times, it was like 10 times smaller than the necessary value. No wonder it didn't work right. The funny thing is that this power supply was used as a night light, with that transformer, with that inappropriate transformer, and it served a lot. It was used for like 5 months, pretty much every night, 6 hours per day. Survived just fine, but had a terrific EMI. Right now it works even better. The EMI is very nice. I don't mind using it now at all. I also did, when I rewinded the transformer, I also paid a bit more attention to isolation, and now I'm pretty sure that it won't break down. It is properly insulated. 3 layers of this yellow tape. By the Russian standard it requires 2 layers minimum, so I'm on a safe side there. Everything is hunky-dory. I'm gonna give you a look at the schematic again. Just works right. You can use mje13002, 13003 transistors, no harm in doing that. But if you want a small kind of power supply for a nightlight or something similar, you can use this circuit. It works great. Pull the core from a CFL, which is this size, use these turns, and adjust the gap in such a way, and trim the core, sand the core down till the inductance is about 29 millihenries. If you get like plus minus 1 millihenry, it's alright. It is more than alright. Thanks for watching. See ya.